In today's lessons, we are discussing the case in which you would have to borrow loans, take out student loans. Now, remember that I said that subsidized loans, the loans in which the government pays your interest rate, are not available to everyone. So, in a worst case scenario, you would have to get an unsubsidized loan in which you do have to be paying interest rate while you're in school. Every single month, you have to pay. You have to start paying it off, and you're accumulating interest. Okay, so let's take a look at two different situations. Now, in these problems, we will again be using the exponential function for compound interest, but we're going to be using the properties of logarithm to solve these specific types of problems. And you'll see why just plugging numbers straight away is not going to give you the answer that you're looking for. So let's take a look at this first problem. It says you borrow $2,000 at a fixed interest rate of 5.75%. You don't want to pay more than $3,000 total. Okay, so you don't want to end up paying all of this money up to $3,000 with all the interest rate. So in how many years do you have to pay this loan so that you don't exceed your $3,000 limit? Okay, you're trying to find how much time do you have to pay this in loan so that you don't end up paying more than this amount. So again, I'm going to identify my variables. In this case, I do know what A is. I don't want to owe more than $3,000. So that is my A. Okay. My P is my principal amount. I know that I borrowed $2,000. Okay. I do know my interest rate. Again, I have to write that as a decimal. Okay, and again, this is compounded monthly. So I'm going to have 12 times. Okay, and now I'm going to plug what I have into my equation and see what it looks like. Okay, so you see how t is the only variable I don't have any information for, which is actually what the problem is asking. It's asking for the number of years. So it makes sense that that's my only variable. Okay, so I'm going to apply some algebra equation solving techniques here to get this simplified. Since this is a product here, I'm going to go ahead and divide, okay, by that amount. Okay, now you see how this whole value here, I can go ahead and plug this into my calculator, but remember, I don't want to round until the very end. So I'm going to leave this here as it is. And this whole thing is raised to my exponent, to my variable. Now, because my variable is part of the exponent, I can't do anything else here. I can't apply algebra techniques in this case. I'm going to have to apply logarithm techniques. So I'm going to change this exponential function into a logarithm function. We've already done this before in class. This is just an application of that. So I'm going to take a logarithm. Remember, this is the base of the exponent. So this is going to be my base in the logarithm. Okay. And since I'm taking the inverse, I'm taking logarithm. This is what my logarithm will have. And my exponent becomes a whole number, not just an exponent. Okay, so here I can divide both sides by 12 now that it's not part of an exponent. And I'm going to go ahead and plug this into my calculator to solve for t. Okay, and I get 7.1 approximately years. Okay, so I have 7 years to pay off this $2,000 debt so that I don't end up paying more than $3,000. And let's take a look at another example. Okay, in this problem, you borrow $3,500 at a fixed rate. You don't recall what your interest rate is, but after 1 year, your total loan value is at $4,000. What was your interest rate? Okay, so in this case, you're trying to find out what R is. You don't know, you don't remember what the rate was, but you do know that in 1 year it went from $3,500 to $4,000. So let's again identify our knowns. Our A is $4,000. That's how much it went up to. That's how much you owe. The initial amount was $3,500. The time, it says 1 year. So the time has been 1 year. And again, it's 12 because we're compounding monthly. And R is what we're trying to find out. It's the only variable we don't know. So again, substitute all this information to our compound interest equation. Okay, and this is what we have. So again, I'm going to solve as much as I can and simplify as much as I can here. I can divide out 3,500. Okay, I'm going to leave this as a fraction so that I don't have any errors in approximating. Okay, so the variable that I'm trying to solve for is inside of the base of my exponential function. So applying a logarithm in this case won't work because it'll place my variable as, again, still part of the base. Since I'm raising the power of this to 12, I want to do the inverse of that. So I'm going to multiply by 1/12 here. I'm going to raise this value to the power of 1/12. And I'm going to do the same thing here. So this 12 and this 1/12 end up canceling. The 1s cancel, the 12s cancel. So all I have left is 1 plus r over 12. And then here I have 40 over 35 to the power of 1/12. So I'm going to go ahead and leave that way. Again, I don't want to approximate yet. And now I'm just going to apply my algebra techniques to solve for r. So I end up getting I'm going to multiply, since I'm dividing by 12, I multiply by 12. And now I'm going to put this into my calculator. I'm going to subtract the 1 and multiply by 12. Okay, and now I get 0.134. Now this is a decimal, so R is usually a rate, it is a percentage. So I'm going to change that to a percentage. So I'm going to move that over twice, and I get 13.4%. And at this realization, if I take a look at this, I realize that this interest rate is pretty high. So probably shouldn't have taken that loan out.